Let's solve exponential equations with the same base. Oh, these are fun. Now, we're going to use the one-to-one property of exponential functions to do this. And I know that sounds like, ooh, so big and fancy. Y'all, it's so nice. It basically means if b to the m equals b to the n, then m equals n. That should make sense, right? If the bases are the same, then the exponents have to be the same. That's like saying if I have 3 to the x equals 3 to the 8th, well, that makes sense. That means x must be 8. That's what the one-to-one property of exponential functions mean. Let's do it. Okay, so we're going to get the bases to be the same. Then we're going to set the exponents equal and solve the equation, right? That's the excitement that we're going to do, and here it is. So, 2 of them on this page. Let's break it down in half. We have 3 to the 2x minus 3 equals 3 to the x. So you're looking at this problem and you say, hey, I recognize that the bases on each side are the same. That means my exponents, 2x minus 3, can be set equal to the other exponent because they have to be the same, right? It makes sense that we would say 3 to the 8th equals 3 to the 8th. Yes, that's what we're trying to do. We're trying to find the value of those exponents. So we're using our gifts of solving. So let's go ahead and get all the x's on one side. So I'm going to subtract 2x from both sides. I have negative 3 left here, and x minus 2x. Remember, if there's no number in front of the x, that's like just a 1. So 1x minus 2x is a negative 1x. I don't want a negative x. So let's divide both sides by a negative 1. Because a negative divided by a negative gives me a positive x, so x equals 3. And there we go. And you can check it. So if x is 3, the right side is 3 to the 3rd. Get that out of there. So this would be 3 to the 3rd. And then over here, if x is 3, well, 2 times 3 is 6. 6 minus 3 is 3. Does 3 to the 3rd equal 3 to the 3rd? You bet you it does. Okay, let's do letter B. 4 to the 3x squared equals 4 to the 75th. Okay, bases are the same, so I can take the exponents and set them equal. 3x squared equals 75. To solve, we have to isolate the x. So we're going to divide by 3 because 3 touching a variable means multiplication. 3 divided by 3 is 1, so I just have x squared. 75 divided by 3 is 25. Now, when I take the square root of both sides, I get x equals 5 or x equals negative 5. Both of these work because either way, when I plug in for x, right, if I take negative 5 and I square it, I get a positive 25. So that works. So this one actually has 2 answers. Let's do 2 more. I have 5 to the square root of x equals 5 to the 3rd. Again, bases are the same, so I can set my exponents equal. Square root of x equals 3. Y'all, make sure you're writing down the steps. Don't try to do this in your head. Don't just hold a calculator. Write down the steps. You'll make less mistakes. To undo a square root, we're going to go ahead and square both sides. So x equals 9. And that should make sense, because if I plug that back in up here, the square root of 9 is 3. And the last one, this is called a challenge problem. I wanted this to be a little bit trickier. 8 and 4. Oh dear, these are not the same. But in my head, I know that 8 is the same as 2 to the 3rd. Right? So I have 2 to the 3rd times x. 4 is the same as 2 squared times x minus 1. So when I look at this, now I have the same base. So I have 3x equals 2x minus 2, right? So now I can solve. Subtract 2x from both sides, and x equals negative 2. If you plug this in, okay? So if I have 8 to the negative 2 equals 4 to the negative 2 minus 1. Well, negative 2 minus 1 is the same as negative 3. What is 8 to the negative 2nd power? Well, we flip it, and that makes it 1 over 8 squared, which is 1 over 64. 4 to the 1/3 to the negative third is 1 over 4 to the third, which is 1 over 64. There they are. They're the same. So you can always go back and check your work. But the key is, if you can get the bases of the exponents to be the same, match the exponent, solve the equation. Fun, fun stuff.